Okay everyone, the rest of this chapter is going to be all about the Pythagorean Theorem. We're going to do 3 lessons on it. So, super important, it's used a lot in mathematics, and for some reason it's quite memorable. I bet for a lot of your parents, they don't remember a lot of stuff in math after grade 8, but I bet if you ask them about the Pythagorean Theorem, a lot of them will remember, especially when I give you the formula, they'll remember that. So, in order to talk about this, we need to do a few definitions here. So first of all, right triangle. A right triangle is a triangle with a right angle. Great, but what's a right angle? A right angle is an angle equal to 90 degrees. So should I draw one of these? Yes, I think I should. This, my friends, is a right triangle, right? And where exactly is the right angle? You know where it is. Right down here. When you have a right angle, the two sides meet and they're perpendicular to each other, we say. Right? They meet at a 90-degree angle right there. That's the right angle. Okay, hypotenuse. Funny word, the hypotenuse is the longest side of a right triangle. So which side would that be? That is this one over here, right? It's the hypotenuse. Now, sometimes it might be hard to figure out which one's the hypotenuse. If you have some like tall, skinny triangle or something, it can sometimes be hard to figure out which side is the longest side. So here's a way you can always figure it out. It is the side opposite from the right angle, right? Across from the right angle. In fact, here's something I made up. This is what's going to make me fame and fortune. If you turn this right angle sign into an arrow, it will point straight to the hypotenuse. That's right. Thank you very much, everyone. The greatest thing I ever did. All right, legs. Legs are the two shorter sides of a right triangle. So you've got the hypotenuse, the long side, and the other one are called legs. Leg and leg. They meet at the right angle, right? This leg and this leg, where they meet up, is right at the right angle. Right at the right angle. Okay, so now that we have all our lingo down, we can actually talk about what is the Pythagorean Theorem. You ready for it? Here it is. In any right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the two legs. There you go. Okay, so I hope that makes sense. See you next video. Alright, I know that's a little bit confusing what's going on there. So let me explain this. Let me draw another right triangle here. And there's my right angle symbol. Now, what I'm going to do is I'm going to build some squares. So I'm going to put a square that exactly fits on this side of the triangle. I'm going to put a square that exactly fits on this side of the triangle. And this is going to be hard, so give me a second. I'm going to put a square that exactly fits on this side of the triangle. Well, it's not perfect, but there you go. So what does the Pythagorean Theorem says? It says in any right triangle, so remember, we started this big drawing with a right triangle right here. So in any right triangle, the square of the length of the hypotenuse. So basically, if you take the hypotenuse and build a square on it, okay, so we built a square on it, and we build squares on these two sides too, the legs, we build the squares on the legs. What this is saying, the Pythagorean Theorem, is that the area of this one, let's call it A, and this one, B, if you add those together, it'll always equal this one. Okay, it's pretty amazing actually. Now, let's go one step further. Let's actually call this side of the right triangle, let's call that A, little a there, that side of the right triangle. And this side of the right triangle, this leg here, we'll call it B. And this side here, the hypotenuse, we're going to call it C. So, I just told you that the area of this square plus the area of this square equals the area of this square. So, how do you get the area of a square? Anyone know? Haven't really talked about it yet, have we? To get the area of a rectangle or a square, you go length times width. You multiply this side, which is A, times this side, which is also A. It's the same, right? They're the same as each other. So to get the area of this square right here, you'd be going A times A. Well, A times A is the same as A squared. So the area of this square right here is A squared. That's the area. Okay, similarly here, if we have B as this side, and we want to get the area of this whole square, we'd multiply length times width. This one's B, and how big is this side? Well, it's a square, so B times B. And B times B is B squared. And finally here, If this side of the square is c, and I want to know the area of the whole square, well, length times width. Length, which is c, times width, which is c. It's a square. They're going to be the same. C times c, which is c squared. And remember what I told you. The area of this plus the area of this equals the area of this. In other words, a squared plus b squared equals c squared. And that, my friends, is the Pythagorean theorem. And that is what I bet a lot of your parents remember. A squared plus b squared equals c squared. Now, here's what's important. This c right here, this c must be referring to the hypotenuse. This is the hypotenuse, this c. And the a and the b, they refer to legs. It doesn't matter which one you call a and which one you call b, as long as you call one of the legs a and one of the legs b. But c is the hypotenuse. In fact, sometimes you'll see people call this a squared plus b squared equals h squared, just so you remember that the last number there has to be the hypotenuse. So, the power of the Pythagorean theorem is that if you know two sides of a right triangle, you can always get the third side. So for example, in this question here, I know this side is 6 and I know this side is 8. So using the Pythagorean theorem, I can figure out this side here. How do I do it? Well, let's go through it. The formula is, I'll just write it again, a squared plus b squared equals c squared. Okay, which side, the 6, the 8, or the x, which side's a? Well, if you look up above, a is one of the legs. So it doesn't matter which one you call a. You could call it 6 or you could call it 8. I'll call it 6. 6 squared. B is the other leg. Well, we already used the 6, use the 8 this time. 8 squared equals c. We don't know c. So if you want, you can just keep it as c squared, or because it has the letter x there, you could also switch it to x squared. Whatever makes more sense to you. It's the same thing. It's just an unknown amount, right? I'll put x since it says x there. All right, next step. We actually do this, 6 squared. Now don't you dare write down 12. That does not mean 6 times 2. That means 6 times 6. 6 squared is 6 times 6, which is 36. 8 squared. That means 8 times 8, and 8 times 8 is 64. Equals. Now, don't write down what that equals yet. Write down x squared, okay? You got to keep that x squared there. Good? Okay, now on the left-hand side, we can actually do this. 36 plus 64. Take out your calculator or whatever. 36 plus 64, you get 100. So 100 equals x squared. Okay, sometimes people stop there. They say, well, there's my answer, 100. What do you think? This is 6, this is 8, this is 100? There's no way. How could it be that big? It's because there's one last step to do. We don't want to know what x squared equals. We want to know what x equals. So, what we have to do is get rid of this squared. We kind of have to do the opposite of squaring. What's the opposite of squaring? We talked about this a couple videos ago. The opposite of squaring is unsquaring, if you want. It's square root. Square root. And what we do to one side, we also do the other. You take the square root of both sides. So, let's look on the right-hand side first here, actually. Square root of x squared. Look, you're squaring and square root. Remember, those are opposite operations. They undo each other. So if you square and square root, you'd just be left with the x. And the square root of 100. So what number multiplies by itself to get 100? It's not 50. That's 100 divided by 2. I'm talking about a number that multiplies by itself to give 100. Oh, 10 times 10 equals 100. So the answer is 10. 10 equals x, or if you'd rather write it the other way around, x equals 10. It doesn't matter which way you write it. There's your answer. So does that seem more likely? 6, 8, and 10? It does seem more likely. And that is, in fact, the correct answer. Okay, let's try another one. Oh, 34, 41, and we have to find this side here. So, first of all, you should be able to tell me something even before I start. What do you know the smallest this y could possibly be? It's the hypotenuse, right? Oh, sorry, I should have my right angle sign there. It is the hypotenuse. It's across from the right angle. It's the longest side. There you go. It's a key. It's the longest side. So it has to be more than both of these. It has to be more than 34, and it has to be more than 41. If we do this work and you get an answer like 36, you've done something wrong. It has to be more than 41. And it shouldn't be outrageously more. We're not expecting an answer like 200 or something. I don't know. I'll make my guess that it's somewhere between 45 and 60. It's just a guess. I might be wrong. But ballpark, I'm thinking it's going to be somewhere in there. All right, let's do this. So we start with our formula. A squared plus b squared equals c squared. What's a? A is one of the legs. Choose whichever one you want. I'll go with 34. So 34 squared plus b squared's the other leg, so it's going to be 41 squared, equals c squared. C is the hypotenuse, and the hypotenuse says y. So you could keep c squared if you want, or you can change it to y squared, since we're actually looking for what y is. Alright, time to square. Whoa, definitely need some calculator on this one. Even yours truly is going to have to go to the calculator. So 34 squared, that means 34 times another 34, which is 1,156, plus 41 squared, that's 41 times 41, which is 1,681, equals. Now, don't do this. Don't add them up right now and get some answer, whatever it is, 2,837 or whatever it is. I'm probably wrong, but don't do that, because then suddenly you're like, what do I do now? Like, I'm kind of stuck. So no, on this side, keep the y squared. Okay, now we'll add these together, and you get 2,837. Is that what I said? If so, I'm mildly impressed with myself. Okay, that is no way. There's no way that that's the right answer, 2,837. What have we forgotten to do? What you'll always do as your last step is undo the squaring by taking the square root of both sides. So when you take the square root here, it gets rid of the squared, you're just left with y. When you take the square root of 2,837, you're going to get some crazy decimal. That's okay. Decimals work. So we'll put it to 2 decimal places. Now just do one. 53 point, rounds up to 53.3. Hey, what do you know? I was kind of right. It was right in the middle of my guess there. Again, I know I'm impressing everyone today. Okay, so there you go. That is how you can find missing sides using the Pythagorean theorem. So, how about this question? A triangle has sides 7, 8, and 11 centimeters in length. Is it a right triangle? How will you know whether it's a right triangle? Well, if it's a right triangle, obviously the hypotenuse would be which one of these? Hypotenuse is the longest side, which would be 11, and the legs would be 7 and 8. So is it a right triangle? I don't know. How will we know? Because if it is a right triangle, then this will be true. This statement has to be true. If it doesn't work out, if it turns out that the left side doesn't equal the right side, then it's not a right triangle. So I don't know if it's equal. I'm going to put a question mark there. It might be equal. So let's try it out. A squared, that's one of the legs. I'll go with 7. 7 squared plus B is the other leg. So 8 squared, equals C. I have C, the hypotenuse. It's 11. So again, I don't know if it's equal. I'm checking it out, but I'm putting 11 in there. Okay, let's square these things. 7 squared is 49, 7 times 7. 8 squared is 64, 8 times 8. And 11 squared is 121. 11 times 11 is 121. Now, we'll add our 49 and our 64, and we get 113, and I'm wondering, is that equal to 121? I'll help you out with that one. Those are not equal to each other, everyone. They're not equal. So if they're not equal, what does that mean? Is this a right triangle? No. If it was a right triangle, you'd have to get that this statement here works, that a squared plus b squared does in fact equal c squared. But in this triangle, it doesn't. So no, you can't put that right triangle sign there because it's not a right triangle. Not a right triangle. If we'd gotten something like 113 equals 113 or 121 equals 121, then you could say it's a right triangle. Alright, find the missing area of the square. Ooh, this looks complicated. But you know what? This is actually the fastest question we've done in the whole video, if you understand this. Because remember, what we found out is, with the Pythagorean theorem, for a right triangle, which I guess this is, that if we take the area of this square, which was built on one leg, and the area of this square, which was built on the other leg, and we add those two together, it will equal the area of this square that was built on the hypotenuse. And usually they just give us the side lengths of the square, but this time they've given us the actual areas here. So what we know is this area plus this area, which we know, it's 72, equals this area right there. In other words, something, whatever this area is, plus 72, which is this area, equals 100. We solved that and we got our answer. How are we going to solve that? Well, just subtract, right? If something plus 72 equals 100, we could do 100 minus 72, and that'll give us the area of, I don't know, this side is B. I guess I could call that whole area there, I'll call it B. 100 minus 72 is 28. So the area equals 28. 28 what? Centimeters squared, centimeters squared, centimeters squared. So I hope that makes sense, that if you are only given the side length, right? Let's say that the question was actually, like if they tell you this side's 3 and this side's 4, just the side lengths, then you're going to have to go 3 squared plus 4 squared equals c squared to get the hypotenuse. But if they tell you this whole area of the square is 3 and the whole area of this square is 4, then you only have to add 3 plus 4 to get 7. You would know that this area here was 7. Okay? Because by squaring, you're effectively building the square on the legs. Alright, I know that last bit's a little confusing, but I'm hoping that makes sense, especially those 2 questions that we did at the top of the page here and at the bottom of the other page. If you're getting those, you're right on track. Alright, we'll continue this next day. Take care, everyone. Bye.